From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Pleasure being here, and today I'm going to talk to you about the OpenSearch project. But just to get to know you with a show of hands, who knows the OpenSearch project already? Okay, we have quite a few hands. And who uses that today? Production, dev test, whatever? Oh, super cool, super cool. Come to me afterwards, I'll give you some stickers. Happy to hear what you do with the project. And a word about myself. I'm Dotan Horovits. And actually this this post that you see here is from last year's OpenSearch Europe that was held in Germany, in Berlin. This year, by the way, it was hosted in Amsterdam. And actually, very excitingly, as we speak, there is OpenSearch North America taking place in California, US. Lots of big announcements there. And actually, just yesterday on the keynote, they announced the launch of a new ambassador program. And I'm honored to be nominated an OpenSearch ambassador. So actually, this is formally my first time speaking as a formal OpenSearch ambassador. So glad to share that with you all. Yeah, thank you. Thank you so much. Really exciting. And besides this, I'm a senior developer advocate for AWS open source team. And besides my day job, I'm also a Cloud Native Computing Foundation ambassador, CNCF ambassador. So if you have any questions also about CNCF, Cloud Native Stack and stuff, happy to chat about that as well after the talk. And I do lots of other things about open source observability. I also have my podcast, Open Observability Talks in English, already 6th year. So if you're into these things, check it out on your favorite podcast app. And as you can see, you can find me everywhere at Horovits. My surname is my handle everywhere, Twitter, Mastodon, Blue Sky, whatnot. So if you are tweeting or posting anything out of this talk, feel free to tag me. Or if you're shy to ask any questions, feel free to reach out after the talk. And let's go straight into OpenSearch. But for those who haven't raised their hands, they're not familiar with the project, a bit of background. OpenSearch started as a fork of Elasticsearch back in early 2021. After the project, Elasticsearch and also Kibana were relicensed away from open source and into a non-open source license. And obviously the community wanted to keep it open, and that was the origin of the fork. AWS stepped up and led this fork. That was over 4 years ago, and the project has actually come a long way in these 4 years. As you can see here, very impressive stats, over 1 billion downloads to date, all thanks to the really amazing community, over 26 releases by now, over 140 repos. It's really a big project and a stack. And very importantly, the community, more than 4,000 members in our active Slack, over 7,000 in the user forums, as you can see, thousands of contributors, dozens of organizations. And the results speak for themselves. If you check DB Engine's ranking pretty consistently, it's been ranked in the top 4. So really glad to see this project coming a long way in these 4 years. Also, last year, actually almost exactly last year, we're now in September 25, so September 24, 2024, OpenSearch project became part of the Linux Foundation. So it's a top-level project under the Linux Foundation, and we founded the OpenSearch Software Foundation as a sub-organization, a non-profit under the Linux Foundation to foster the open governance and open collaboration. We have a governing board in place, technical steering committee, technical advisory groups, and lots more. And really, you can see organizations such as SAP. I know that we have a few members of SAP here, so a big thank you to SAP for engaging and supporting this, Uber, NetApp, and many others that have already joined and are helping to steward the future of this project. And really nice to see in the past year since we joined the Linux Foundation, the project moved up from being the number 70 on the Linux Foundation projects by contributor activity to top 20 or so. So really, really nice to see how moving to the Linux Foundation made a difference and got the project more inclusive for everyone to take part of that. So that's a bit about the community and the project's history. And now let's talk about what the OpenSearch stack is about. So OpenSearch, at its core, OpenSearch core is a distributed search engine built on Apache Lucene with essentially a document storage and indexing capabilities and with built-in vector database. So essentially what you do, you take a document, think about a JSON, you store it, and then obviously it can contain unstructured text, so you get full text search as part of it. And just like then, you can query that based on a RESTful API very, very intuitively. That's the core. Then you also have the front-end piece, the OpenSearch dashboards that allow you to query visually using a tool, and also to build dashboards, alerting, all the things that you would expect. Also team management, workspaces, all the goodies that come with a proper UI. And the last piece, maybe to mention, the major piece is the component is the data prepper, which is a lightweight data collector component for enriching, transforming, processing, aggregating your data, essentially massaging it and preparing it for storage. So these are the main pieces. There are also client libraries and integrations and lots of other things that I'll talk about later. And of course, you can easily deploy it on Kubernetes. I know we're in ContainerDays, very easy. You have the Helm charts and you have everything in place. So don't worry about that. Now let's talk about how people use OpenSearch. And like any database, of course, usage is very, very diverse, but I would say that it falls into these 4 categories that you can see here. So first and foremost, OpenSearch is a search engine, so lots of people use it for highly scalable search engine for enterprise catalogs, for e-commerce, every type of textual search applications that you'd need. Also, we see a lot of demand for it for log analytics and observability solutions. Then we see growing use of that as a backend for AI and machine learning applications. Everything is AI these days, but this is squarely within this realm with the vector database that it has, with integrations with LangChain, Llama Index, and so on. And lastly is security analytics for those who need it for investigating, responding on threats in real time. So these are the main use cases, and I'd like to now delve into at least some of these in the time that we have. So let's start with the search engine. As I mentioned, search is I guess, the most known use case for the project. Essentially, search engines in general, what they do, they match objects or the terms that you provide to objects in your catalog. That's really much in the essence, and you can see here in the example. Let me see if this one works. And you want to show here, you see? So you have convertible olive couch, and you get lots of results based on the free text search, lexical search, keyword matching, and it's also ranked. So I don't know if you can see that, but essentially you get ranking for each result, how close it is to the terms that you provided, based on occurrence models and so on. So that's one aspect. There's also facets. Facets is what you usually see here on the side, on the left-hand side. Essentially, when you tick the box and you want to say, no, I want to see only couches from this material and this color, this brand, this style, and immediately it narrows down your search based on these facets. So faceting is baked into the search platform, of course. Geospatial. If your data contains coordinates, then you can also run searches based on bounding boxes, intersections, and so on to find things that are in your relevant area. Beyond the exact matches, it also supports fuzzy matching. So think about if you misspelled one letter, maybe 2 letters, you define what's the distance, and still you want to find the right results. A bit like what you do when you Google and it says, did you mean that, when you misspell it? So fuzzy matching is supported. And lastly, vector search, in which case you represent data as sort of vector embeddings. I'll talk about it more soon. So that was about it, but I want to actually show you instead of talking about it. So I want to switch over and show you something that I prepared. Let's have a look. Where's my mouse? Here it is. And of course, wishing for the demo gods to be with us. Here we go. Let's see. Okay, so this one is a simple e-commerce data, very simple for the search case that I talked to you about. You get, in this case, the purchases that have been made in your online shop, and then you create visualizations. You create these, right? You can create whatever is comfortable for you to show things that would be intuitive, like the sold products per day, sales by gender, and you have the breakdown, male, female, whatnot, average sales price, average sold quantity. You can see trends over time. You can break them down according to, I don't know, women's clothing, men's shoes, whatnot. You can track and correlate promotions. You can see them where the purchases come from on an online map, where it comes from around the world, top selling products, and so on. So this is essentially what you do. And by the way, when I talked about documents, this is all based on the documents that I mentioned before. So just for you to see what the document is, if you look at the JSON here, this is essentially the document. You have lots of information that you'd expect, like the currency, first name of the customer, full name, gender, and so on. You have lots of information about the product, manufacturer, product ID, category, and so on. So this is what you give, and based on that, you then do the analytics, you run queries, and you build your dashboards on it. This is the JSON, but of course, much, much easier to look at it as a table format. So that's very quickly just to have a look and see what I mean by that. Let's go back to the slides for a second. Here we go. Where's my slides? So we saw the demo. That was the search, and now I want to get to observability, the second use case. On the observability front, you can use OpenSearch to detect, diagnose, and remedy issues that affect performance, scalability, availability of your applications or infrastructure. Basic use case, of course, as I mentioned before, is log analytics. You throw all your mounts of logs into the OpenSearch cluster. You don't need to do a lot before, and then you can run full text search and find interesting things on your logs. And lots of tools around that. We have beyond the discover and the dashboard, you have also log tail, log surround, log patterns, and so on. And of course, you can query your data based on Lucene, for those who are comfortable with the Lucene query language, open source based on Apache Lucene. Also, you have another option based on PPL, a piped processing language. This is another open source query language that we developed as part of the OpenSearch stack. That's actually a query language across the different signals. So you can use the same query language, PPL, also for querying your metrics, your trace data, and so on. So one of the advantages. And by the way, we even added natural language querying. So even if you're not comfortable with either, you can run natural language queries, and then this will translate it into your PPL query. And then you can tune it, but at least very easy for those who are not familiar with the formal domain-specific languages to start with a natural query. So pretty cool, talking about AI, translations, that's pretty cool. What else? It provides integration with lots of frameworks. You can see some here from the cloud-native stack, like OpenTelemetry, like Jaeger, Prometheus, and so on. And you can use OpenSearch also to visualize metrics from Prometheus. We're going to invest a lot, by the way, in the coming year on the version 3. I'm going to talk about it later. So this was about it, but again, I prefer to just show you instead of talking about it. So let's have a quick look at the demo of what it takes to do that. So let's do that. Go back here. And I want to this time start the journey from the discover pane. Lots of people spend time in a Discover pane. This is, again, the raw logs. So this is an example of web logs, okay? You throw your web logs onto the cluster. A log would be very similar to what you'd expect, right? We have here the, let's look at the table view this time. Geo-coordinates, we have the host, we have the IP, machine information, operating system, RAM, and so on. You can see all of that here. Actually, I can even make it a bit nicer if I choose that I want to see the host and the IP. And then I can see, and I can add some more fields that are most interesting for me before drilling down. And I can run the queries on them. This is the querying interface. And then, again, as before, I can then create dashboards. The example dashboard like this one, where I can see unique visitors. I can see visitors by operating system, the breakdown, how many from iOS, how many from Windows 8, and so on. I can see the response codes over time and annotations. Annotations are these red, I don't know if you can see that, the red dots here are actually incidents that happened. So you can really see, okay, I don't know, a security breach happened, and then I can see the correlation with, in this case, the response codes on that time. Unique visitors versus average bytes to correlate. I can see which types of assets were downloaded, like CSS and GZ and RPMs as a scatter plot or as a table. A heat map, when was my site being heat the most, hotspots, and so on. Again, a map where it comes from around the world. This is the sorts of things that you can do for very simple observability on your, in this case, website based on your weblog data. And let's, again, switch it. Where is that? Here we go. Sorry. Now, let's talk about the stack. So essentially, the way that it goes for observability is that you use the data prepper to ingest, enrich, and transform your data, your telemetry, whether log data or tracing or time series data for your metrics or whatnot, and then essentially make it optimized for analysis, and then you store and index the data on the OpenSearch core, across logs, metrics, traces, and then you use the query language to query the different signals. PPL, at least, it allows across the different signals. And then you have the UI that enables easily visualizing the data with dashboards for fast root cause analysis. Let's talk a bit more about the observability UI that I mentioned before. So one of the biggest areas of focus of development in the OpenSearch project has been for us actually the UI, the user experience in general, because with the sheer volume of telemetry that we all experience, we know that it could be overwhelming, and finding the right thing in an easy-to-use manner is essential. So lots of tools that we've made available within the project to manage and visualize your data, to identify and respond to issues quickly, to share insights within and across your team, the team collaboration aspects, and it all has to be accessible, simple to manage. The example you see here on the screenshot is actually one of my favorites. It's anomaly detection. Again, talking about AI. So there is a way to plug in anomaly detection with a model of your choice, and then it monitors the behavior of certain telemetry over time, and then it can flag when anomalous things happen after it learns the normal behavior, the steady state of the system. So pretty cool to get more, let's say, dynamic alerting rather than the static ones that we define static thresholds and so on. The ecosystem is another important area of focus for the OpenSearch project. Every monitored system has its own requirements. For each and your systems, you have your own data sources, your own applications, your own storage, processing requirements, and more. And with OpenSearch, we want to be able to allow you to tailor it to your own needs, to your own observability pipeline that suits your data. So the ability comes with these set of integrations, powerful tools for collecting, managing, visualizing information. You see some cloud-native projects that you can see, some tools, and that's not an exhaustive list by any means. So that's about the integration. And now let's talk about AI and machine learning. So what we see in the search realm is that the search is evolving from the lexical search that we talked about so far, the keyword matching, into more semantic search that's based on meaning and intent. So OpenSearch actually offers a full-fledged vector database for storing dense vector embeddings and running similarity search on these embeddings. So it supports both exact KNN. KNN is the K nearest neighbors. These are the algorithms that allow you to find relevant matches on the semantic searches. So both exact KNN and approximate KNN algorithms in it. It supports different, you can see, I'm not going into HNSW, IVF, it's a whole different talk, but essentially this is how you calculate the proximity in the multidimensional space. It supports multiple modalities, so not just text search, but also audio, video, images, PDF documents that themselves have multiple modalities. You have the thing about a typical PDF that has a graph and a chart and a table and a header and a paragraph. Each one of these is actually a different modality when you look at it in the whoever knows and got to deal with machine learning. So you can actually have different models analyzing the different modalities, even multimodal models. So models that will put all of these modalities into one space. You can bring your own LLMs of preference to work with that. There's an MCP server baked in for agentic AI and lots more. So I have a whole different talk that I gave actually a couple months ago in Berlin about that for a data and search context. But just so you know, happy to answer questions if there are. Lots of things done around that. Performance. We're all engineers, and performance has been a point of emphasis for the OpenSearch project throughout these 4 or 5 years. A lot of users choose OpenSearch for its ability to ingest, index, and store and search massive volumes of data. And with huge data sets, of course, it comes at a premium, both in the real-timeness of getting our responses, also in terms of cost of storage and so on. So a lot of emphasis has been into optimizing that across different parameters. We want OpenSearch essentially to be the most performance search engine. That's the mission statement. So you can see indexing throughput, query latency, storage space reduction across the different ones. This is not the latest numbers. I'll show you a bit more numbers from the latest release, but just so you know, performance is top of mind for us always. And now, let's talk about some updates, because we have some hands that were raised. You know OpenSearch, you want to know what's new. As I mentioned, OpenSearchCon North America is taking place these days, so some updates come from there. But I guess the biggest update and the hottest news is that 2 months ago, back in May 2025, we released the latest major release, version 3, which was the first major release in 3 years for the project. So that was a really, really exciting milestone for the project. And then in June, we released 3.1. And a couple of weeks ago, just in August, ahead of OpenSearchCon, we released 3.2 at Open Source Summit Europe in Amsterdam. We run, by the way, an 8-week release cadence, so the project has been moving very fast. And V3 is really big, and I want to give you a taste about why it's so big. So let's start with the underlying infrastructure, okay? With Lucene and the Java JVM that powers the underlying system, we've upgraded to the latest major release of Apache Lucene, version 10, and also upgraded the JDK to a minimum of JDK 21. I think maybe even moved up to 24, but anyway, definitely a major jump. And this infrastructure upgrade gives us many benefits. So, you know, things such as hardware level enhancements, SIMD vectorization, more efficient posting and decoding, and more. Also on the Node.js, 14 has been deprecated. Anything less than that, deprecated by the Java 3 client. And these changes also make the project more future-proof. So that's on the infrastructure level. Also, one of the biggest evolutions comes from the way that OpenSearch ingests transports and manages data. Okay, dozens of new features have been released around these areas in V3. I'll give you just 3 examples to give you a sense, things that will probably impact most of you that use OpenSearch. First is the support for gRPC and protobuf for faster and more efficient data transport and data processing for OpenSearch deployments, which unlocks also transport frameworks such as Apache Arrow and Apache Flight, which are optimized for large data sets and distributed networks. That's one. Another example is the pool-based ingestion. So this gives you more control on the flow of data and when it's retrieved. And beyond this flexibility on optimizing the efficient ingestion, it also means that you can now ingest from streaming frameworks such as Kafka, Kinesis, Pulsar, and so on. So you can pull that from that. And another significant architecture change is the reader-writer separation. So you can now able to keep your indexing and your search workloads separate in dedicated nodes. So think about users with log analytics users, for example, that has like scaling and indexing millions of documents per second. Or on the other hand, enterprises that want to configure 20 or more replicas for supporting their e-commerce search traffic. On the performance, I promised to show you some updated stats. So really, version 3, you're going to see a big leap. You can see the latency graph dropping there on the going down. And actually, I don't know if you notice, let me see if I can highlight this. This is a logarithmic scale. Okay, so when you see it going down, just to make sure that it fits into the one graph, it's a logarithmic scale. So imagine this is a major drop, not just as moderate as it seems. So really amazing improvement in the latency and in other parameters as well. And we've enhanced so a bit more on the observability side. We've enhanced query insights. So this is a great way to investigate your long-running queries. You have a query, it takes a lot of time. Why the heck does it take a lot of time? You have a visual tool to actually break it down and see what goes on there. Smarter anomaly detection with contextual launch. We've upgraded our tracing and correlation capabilities, added cross-cluster search for traces. Lots of improvements on the piped processing language, the query language that I mentioned before. Over 20 new commands were added there. One of the most interesting one for me, at least, is the support for querying nested JSONs, which is pretty cool, and transforming nested JSON into tabular format for easier querying. And there's a lot more on the version 3, support for OpenTelemetry, for Prometheus that I mentioned before, on the time series data, natural language queries, new APM experience, multi-source panels that will let you overlay logs, metrics, traces on one canvas, defining SLO targets directly in the dashboards with real-time status indicators, automated reports, and so on and so forth. So not enough time, happy to talk about it after, but lots of more goodies. One thing is that I had an episode about this, the latest version on my podcast on Open Observability Talks. I hosted the governing board chair, Carl Meadows, and the release manager, Pallavi. So check out, scan the QR code, and you can listen to a full 1-hour episode with authoritative sources about the version 3 release. Really a nice episode that I had with them. And also, join the project. GitHub, Slack, forums, user groups. We have user groups, unfortunately not yet here in Hamburg, but we have in Munich, we have in Berlin. I hope maybe someone here from Hamburg wants to start a new user group here. Reach out to me, happy to talk about that. But really, over 20 user groups around the world. I've pulled all the useful resources into one link, so you can scan this QR code and you have all the links, including roadmap, playgrounds, and so on. Check it out. And of course, I'll be here today and tomorrow to answer any questions beyond the session that we'll have now. And also, you can reach out to me at Horovits, as I said, anywhere I'm there. Happy to also answer after the conference. I'm Dotan Horovits, and thank you very much for listening.
Does OpenSearch dashboard supports PERSEs? Okay, so first of all, for those who don't know, PERSEs is a sandbox project under the CNCF that provides visualization for metrics primarily, Prometheus compatible, but also others. That just for background.
So asking if it supports processes, like it's different tools, I guess, in a way. They try to cover the same ground of creating visualizations over telemetry. So currently, 2 different tools working on the same data. You can choose which visualization you want. There are discussions to see where there could be collaboration, but currently 2 options for you to choose for visualization.
All right, next one. So for teams using Elastic 8, is migration to OpenSearch hard, and are the client libs for a common framework, or is it transparent to Elasticsearch?
So like any good solution architect, I would say it depends. So any migration, it really depends the exact versions, the exact feature sets, the workloads. I would say that it's for version 8, it's not such a big change. If you look, for example, on the APIs, the RESTful APIs, you'll see that it's very much very similar, maybe besides the regex change from Elasticsearch to OpenSearch. But it really depends, like those who use classic lexical search, for those who use vector search, of course, there it's much more different because it's a whole development that is made only on OpenSearch. The client libraries, the Elasticsearch client libraries, although they're Apache 2.0, they're blocked from working with anything that is not the certified Elasticsearch. So there's an if statement there that will check it. So it will not work with anything other than Elastic's instances. You will have to do the adaptation, their client libraries, and also depends on the signals. Actually, our preferred path, for example, if you use traces, is actually to use OpenTelemetry SDKs. Which is also the industry, where the industry is heading. So I think migrating to OTel, for example, would be a future-proof path, not just for the migration, but also in terms of aligning with the industry. So this is a long answer for it depends. Happy to talk about it afterwards to hear more about the specific migration you're looking for.
All right, next one. Provide OpenSearch default dashboards, or have it a simple integration to download dashboards from the community like Grafana.
So there is pre-made content like Nginx and Kubernetes and other things. Some of these, by the way, that I showed you, and it's available. One of the nice things that you have with OpenSearch, I think starting version 3, is that you have workspaces. So depending on your use case, I talked about observability and I talked about search and others, you can actually click to start a workspace in that context, and your entire, let's say, view of the dashboards will be aligned with this use case, including the offered content. So yes, there is, and it's a community effort. So if you have something cool that you want to share and publicize, we're happy to get more content there out there.
All right, next one. Does OpenSearch support alerting? Alerting?
Yes, OpenSearch definitely does.
Easy. What would be a situation or a context in which you wouldn't recommend using OpenSearch? None?
No, it's again, it depends. If you have something that works for you and you're happy with it and you have no problem, then stick with what you have. So it's not, if you have some very specific needs in, I don't know, specific signals or legacy systems and so on. So it really depends. OpenSearch is good in the areas that I talked to you about. And also in terms of, depending what's your concerns. Some people are concerned by being locked into a certain vendor, and having a foundation-led open source is a significant business risk reduction for them. So it really depends on what's your priorities for choosing your tools, I guess, for your organization.
Why is it so hard to get TLS working with custom CAs? Not really.
I'll take that offline. It's very specific. I understand why it's so hard and for whom, and then I can answer this question.
That's also the kind of question that, well, anyway.
Yeah.
What's the roadmap for OpenTelemetry? Does it require Yiga? Will you provide default dashboards for it?
So the roadmap, actually, OpenTelemetry is already supported. You have, for example, in data prep, you have a native OTLP endpoint. OTLP is the OpenTelemetry protocol. So you can actually send native OTLP. You also have, in the OpenTelemetry collector, and I'm sorry if I'm diverging to OpenTelemetry, but I hope that most of them know, but OpenTelemetry collector is the piece that collects and then sends it to the backend of your choice. So if your backend of your choice is an OpenSearch cluster, you have, as part of the default bundle, you don't need to install anything. The default vanilla OpenTelemetry collector will come with an OpenSearch exporter that can allow you to send it directly to an OpenSearch cluster. So, and lots of other things. Also now visualizations, you talked about visualization, baked in for OpenTelemetry in the UI, in the dashboard, so, and a lot more on the roadmap for V3. So the answer is yes, and happy to elaborate later.
The log scale tells that it becomes harder to obtain smaller improvements, so perhaps OpenSearch is most performance search already. To be honest, I don't really get the question.
Yeah, the question is not clear. Maybe
anyone
in respect, yeah, let's take it offline unless someone wants to clarify the question.
All right.
Otherwise,
when using OpenSearch as the logging backend with the logging operator stack, what is the best practice to manage the ILM in a declarative manner?
Again, I think it's very elaborate and counts on specific knowledge for the audience and not for everyone. So I'm happy to take it offline afterwards.
I'm fine.
Yeah.
Does OpenSearch integrates? All right. Does OpenSearch integrates with vendor-specific data like Datadog?
So OpenSearch has several integration suites that I mentioned before. It's open source, and lots of integrations were created for it. Best thing is just to go to the integrations page on TechDocs and see for your specific stack what's supported.
All right, 3 last questions because we're already late. How do the performance improvements compare to the latest Elasticsearch releases?
I'm no Elasticsearch expert, so I can't comment on any other vendors. I can show you just the numbers of the OpenSearch project. I shared them there, and actually we have a regular nightly build and regular performance that is open source, both the flow and also the results. You can open an interactive dashboard, because that's what we do, so you also have a dashboard for that. You can explore the performance yourself. We have the big 5, like the classic suite of performance benchmarks, so you can explore it and get the hand of it yourself.
All right, 2 last questions. Does the vector search feature allow filtering on metadata for the initial query?
Yes, there is pre-filtering as well as post-filtering, definitely.
That's a quick answer, I think. Last one, VictoriaDB, does it support multi-modal search?
Yes. So I mentioned before, sorry for being very brief on the vector database, because I assume that most of the interest will go to observability and search, but supports multimodal. You plug in the multimodal transformer model that you choose, and then it will create the embeddings, and you store the embeddings, and then you run the KNN search on the multimodal search, just as I mentioned. Videos, audio, and by the way, I can show you after if you want to come. I'll show you even a playground that you can play it with yourself and experiment that.
Thank you all for all the questions. Thanks, Dotan, for answering them, and thanks again for this great talk.
Thank you, everyone. Have a nice day.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.